Hello folks, hope you guys are doing well today. So what I'd like to do is walk you through a very brief lecture on chemical bonds. Now, a bond is an interaction or due to the interaction between electrons of partner atoms in a molecule. So electrons we know are swirling around the outside the nucleus of an atom, and those electrons can behave in different ways. And so depending on how the electrons behave, different combinations of atoms can be created and they take on new properties. So there are three types of chemical bonds or forces, intermolecular forces we're going to look at: covalent bonds, ionic bonds, and then hydrogen bonds. We'll start with covalent bonds. Prefix co means together or with, and in the case of covalent bonds, electrons are being shared between partner atoms, and that is subcategorized as either polar or nonpolar covalent bonds. Now, if we say something's polar, that means that an extreme. So if you look at the image on the right, image B, that is a polar covalent bond. The electrons are still being passed back and forth between the hydrogen and chlorine partners, but you can see that the electrons spend more time around the chlorine. When that happens, since electrons have a negative charge, the region of the molecule where the chlorine is has a partially negative charge. That's that sort of fancy S with the minus sign. So that means it's a more negative region because, again, their electrons are there more often. The part of the molecule with the hydrogen, it gets less time with the electrons, and so that means there's less negative charge, so it takes on a partial positive charge. So in the case of polar covalent bonds, you create these molecules that have partially positive and partially negative regions, so they act differently when they're around each other. The partial negative regions of one molecule will be attracted to the partial positive regions of another molecule. Now, in the case of nonpolar covalent bonds, that's what you see in image A. The electrons are being shared between partner atoms, but they're being shared equally. If you have two chlorine atoms, they have the same electronegativity, so they have the same sort of pull on electrons. So the electrons get passed back and forth between partners, but the electrons spend about the same amount of time with each partner, so there's no uneven distribution of charge. As a result of that, those molecules tend to be nonpolar, and so neighboring molecules aren't that really attracted to one another. That's what we see with oils. If you put oil on a plate, the oil will sort of spread out and be amorphous. That's because it's made of a bunch of carbon and hydrogen atoms, and they share their electrons really well, equally. Now, things are different when we get to ionic bonds. In the case of ionic bonds, electrons aren't shared, they are transferred. They're moved from one partner to another. So here, in the case of sodium chloride, an electron is moved from the sodium ion, or from sodium to chloride. When chloride or chlorine receives that extra electron, it becomes a chloride ion. It's negatively charged. When sodium gives up its electron, it becomes a sodium ion. It's positively charged. And those opposite charges attract one another, and it holds them stable. Now, this works well in an anhydrous situation when there's not any water. But in the cells of our bodies, they're filled with water. So because water is polar, it will disrupt the ionic bond between something like sodium chloride, and then it dissolves that. The last idea we're going to talk about are hydrogen bonds. Now, it's named bond, but it's technically not a chemical bond between electrons. It's what's called an intermolecular force. It's an attraction between neighboring molecules. So if you look at those water molecules, you have the red oxygen and the two white hydrogens. Oxygen is electronegative. It pulls the electrons toward itself, and so this forms a polar covalent bond. Oxygen takes on a partial negative charge. The hydrogens take on a partial positive charge. So an individual water molecule is held together by polar covalent bonds. They are polar bonds. They're covalent bonds. But because oxygen has a partially negative region and a partially positive region, when water molecules are around each other, they'll actually pull on one another. And when they do that, that creates this attractive force that's referred to as a hydrogen bond. If you've ever seen water beat up on a window or anything like that, it's because the water molecules are actually pulling on one another. And they're pulling on one another because the negative region or the partially negative region of one water molecule is attracted to the partially positive region of another water molecule. And then again, it creates this sort of cohesive force that helps hold a bunch of water molecules together. All right, so that takes us to the end here. We were looking at covalent bonds, that's polar versus nonpolar, ionic bonds, and then this intermolecular force of hydrogen bonds. if you would, just sort of go through those, make sure they're clear in your head. And then as we progress through chapter 2, we'll see how that stuff applies. All right. Thank you so much, guys.